Algebra 2, 6.9a, direct variation and constant of variation. Okay, we're getting deep into Chapter 6, and now we have 16 videos before this. If you haven't seen them, you might get lost or confused, okay? So I want you to remember, it's easier to climb a ladder if steps aren't missing. So if you've missed some of the videos, you might have a hard time, okay? You can just click on this description and watch them real quick. Direct variation is a functional relationship that can be described by the equation y equals k times x. When k is a non-zero constant, it can't be a zero. And k is a value that stays the same, though the x and y values may change. Whenever a situation translates to a linear function, the function of x equals k times x, or y equals k times x, same thing, where k is a non-zero constant. We say there's a direct variation, or that y varies directly with x. The number k is the constant of variation. So if Tala earns $20 per hour, we can make a function table for the hours worked and the total she earned. And for each hour she works, it's going to go up by $20. $20 is the constant of variation. Her earnings vary directly with the time she worked. And those are ordered pairs. We can actually graph that information. Okay? We can find the constant of variation and an equation of variation where y varies directly with x and where y equals 32 when x equals 2. We know that the ordered pair 2 and 32 is a solution for y equals k times x. We can substitute the values and solve for k. So we'd have 32 times k times 32 equals k times 2. And we can divide each side of the equation by that 2 to isolate the k, and we get 16 equals k. So the constant of variation is 16, and the equation of variation is y equals 16x. So if y equals 16x, we can make a function table and plug in values that'll make y equals 16x true. We can graph these points, and our constant is going to be our slope. It's going to equal 16. We're going to have a rise of 16 over a run of 1. And when it's simplified, that's going to be our constant. Okay? That makes a pretty steep graph, doesn't it? It's almost vertical. All right, so let's look at this one. The length of a spring varies directly as the force applied to it. When the spring is stretched 4 inches, the force is 8 pounds. So this spring is just sitting here in stasis. That means it doesn't have anything pulling or pushing it. It's not stretched or squished. Stasis means it's inactive, caused by opposing equal forces or standing still. So the opposing equal forces are no pulling and no pushing. See? It's not stretched or squished. Now, if the spring is being stretched 4 inches by a force of 8 pounds, we can find the constant of variation and the equation of variation. We're going to let L be the length of stretch in inches and F be the force in pounds, and K is going to be our constant. So that means we have L equals K times F. We can substitute the values and solve for K. So we've got 4 equals k times 8. We can divide each side of the equation by that 8, and we know that our constant of variation, k, is a half. Now our equation of variation is y equals half x. If y equals half x, we can even say the function of x equals half x. Because remember, for x and y, there's a lot of different names, and y can be the function of x. It's the range, the output, the y coordinate, okay? We can make a function table that'll make this equation true or this function of x true. When we graph it, because these are our ordered pairs, we can see we have a nice constant slope, don't we? Our constant is the half. And in this graph, because 4 squares is a 1, 2 over 4 is a half. So our rise is 2 and our run is 4. That's equal to a half, and it goes up nice and smooth and constant, doesn't it? Each is the same. So our constant is a half, and our graph is linear and constantly rising by the same amount. All right? So our next video is going to be 6.9b. We're going to talk about inverse variation. I'm going to put this video in the Algebra 2 playlist, and the Algebra 1 videos that are similar or helpful are 12.5a and 12.5b. We talked about direct variation in those back in Algebra 1 last year. I'm going to add the links to any Algebra 2 videos from Chapter 6 that are current and helpful. And hopefully all this information I'm giving you and all these links in this description will be able to help you, okay? So it's up to you to click on them and use the help I'm giving, okay? I hope you're doing well. I hope you have a great day. And I also hope I'll see you next video. Bye.